One of the biggest problems we have in our industry is that people don't do their homework. Take 0. All right, so I came across this post this morning from Jeff Schrader from HiByte. Those of you in the Discord server, Jeff Schrader is JS, one of the most brilliant engineers I've ever met in my life. Absolutely brilliant dude. He's been in the industry for community now, I think probably 5 years, active participant. He was originally with the end user, and then he went to HiByte, and he's the product manager for the HiByte intelligence platform. All right. And he posted this on LinkedIn today. Manufacturers should reconsider their use of MQTT and Sparkplug if they spend more time engineering around it than making use of it. Okay. And so I just scrolled through like some of the comments, right? Mark Friedman from My AI, that felt like a slam dunk mic drop. The few times I've worked with Sparkplug, albeit before AI was my weapon of choice, I was like, oh, brother, why is this so opinionated? Niels Eric Anderson, MQTT is good for the use cases it was designed for. Unfortunately, most of the implementations don't fit that use case. Andreas Hein, Jeff Schrader, true. Rick Bellata, truth. Tori from also HiByte, we all need to speak more plainly about what things are and what things aren't. Thank you. David Schultz, use case, user experience, technology, good stuff. Omar, I like how you're broadening the aperture, Schrader. And Ernst Holger, must be a post from last year. The UNS crowd has already moved on to MCP. All right, so here's my comment, and then I'm going to go through a detailed breakdown of MQTT and Sparkplug. So I said the question that they should ask is, what problem am I trying to solve that is pushing me to engineer around MQTT? The beauty of the protocol is its simplicity. There is a direct correlation between the adoption of digital transformation strategies and the growth of MQTT. They are inextricably linked. One of the biggest issues we've had in our industry is that really we have two fundamental issues. You have the people who understand the technology either fall in love with the tech and never connect it to a specific problem that manufacturers have, and then they're frustrated when people don't adopt this amazing technology that they have developed. They're like, this is fucking awesome, just ask me. As opposed to starting with the problem the customer has and working their way back, which is what Dave Schultz talked about. He said, start with the use case. Really, it's start with the customer problem, right? The second issue that we have in our industry, specifically around this topic, is that the technologists who are tasked with leading digital transformation, they don't speak the language of operations. And if you don't speak the language of operations, then you'll never understand why you're using the technology you're using. And it's been a massive issue in our industry. It still is to this day. So I said it's never been about one protocol over another, or one standard over another, or one platform over another. It's always been about ecosystem and solving problems on common infrastructure. This shows just how far behind the industry has been compared to the capabilities of the technology available to them. The fact that Jeff Schrader can even post this today and anyone would even know what he's talking about is a win for our industry. That is an indication of digital fluency, right? That's the fluency of the market is increased. Therefore, a post like this resonates today. 10 years ago, no one even knows what the hell he's talking about. 5 years ago, a fraction of people know what he's talking about. MQTT was invented in 1988 and 1998, 99. Okay, it became known to the world in 99. In 14 is when it became known to industry, even though that's who it was originally developed for. And today, in 2025, we are finally having this actual conversation about why it is people misuse technology. Well, the truth is they're not misusing technology. This is one of the funniest things. I laugh at this all the time when you have calls with people and they complain, well, the customer is using the product wrong. No, they aren't. You built it wrong. If they're using it wrong, you built it wrong. Okay? Murphy's Law says that what can happen will happen. You as the engineer must take into account what can happen. You as the software developer, you as the product manager, you must take into account what can happen. You want to know why it is that software and industry is hidden behind paywalls and requires 2 weeks of training for you just to get the fucking thing installed? It's because the people who build industrial software never take into account that what can happen will happen. And rarely do they start with the customer problem and work their way back. The case of MQTT and Sparkplug, both of them exist because of very specific, widespread issues in industry. But the implications of the technology expanded into the consumer markets, retail markets, all over the world. Okay, that's how powerful MQTT and Sparkplug are as solutions, as technological solutions. And so I just went through and I just asked a series of questions. Mark Friedman, because of the problem, he said, why is this so opinionated? And I said, well, because of the problems it was trying to solve. Publishing message as a device node, edge of network node, compression, and coding specifically. And then he said, and then he explained a little bit further. Niels Eric Anderson, MQTT is good for the use cases it was designed for. Unfortunately, most of the implementations can't fit that use case. And I said, well, which use cases was it designed for? Because if based on Neil's argument, it should only be used in oil and gas where they're using satellite communications, because that was the use case it was designed for. Okay? Except they didn't build technology that would only apply for that use case. Tori said, we all need to speak more plainly about what things are and what things aren't. Thank you. And I said, well, what is MQTT and what is it not? I love Tori, by the way. I'm not picking on anybody here. And then Ernst, must be a post from last year. The UNS crowd has already moved on to MCP. He's probably joking. But I said, Ernst, and if you aren't becoming fluent in MCP and agent to agent, you'll be an unemployed data scientist. You can screenshot that and put it on your wall. And he said, I actually just see this. I'm already working with Claude Code and use a set of very useful, so I should be good then. Working with LLMs will be a required skill set, but I'm pretty sure the tooling will change along the way. And if history is any guidance, AI companies will have their own version of agents and protocols to make their products sticky. Yep, he's right. All right, let's go through what MQTT is and what it isn't. Okay, let's talk about Sparkplug. Let's answer the question. Okay, so what is MQTT? Arlen Nipper, Andy Stanford Clark, Arlen Nipper from Cirrus Link, Andy Stanford Clark from IBM. They worked together with Phillips 66. They were working with Phillips 66 in 98, 99, and they invented MQTT, messaging queue transport telemetry, to solve a very specific problem. And I've articulated it here clearly. The reason I've done this, and I'm not going to riff it, is because I want people to be able to come back to this video. I want you to be able to share this video, and here you go, okay? So the problem they were trying to solve was that they wanted to monitor oil pipelines in remote locations using unreliable and expensive satellite communications. The fact is that all network communications are really unreliable, but when it comes to satellite, it was super, super expensive and very low uptime. MQTT wasn't created as a general purpose messaging protocol. It was engineered to solve the very specific, expensive problem of monitoring remote industrial equipment over unreliable, costly satellite communication connections. The report by exception approach that saved oil companies millions in satellite charges became the foundation for modern IoT communication, Internet of Things, including the industrial Internet of Things. MQTT is to IoT what Sparkplug B using MQTT is to IIoT, proving that sometimes the most practical solutions to immediate problems become the most transformative technologies. This is why MQTT feels so natural for industrial applications, because it was born in industry. All right, MQTT is a lightweight, publish-subscribe messaging protocol originally designed in '99 for real-time SCADA systems operating over satellite links. Despite its name suggesting messaging queue, it's actually PubSub. Okay, that enables efficient real-time communication between devices and applications over unreliable networks. One of the biggest things that Arlen always talks about with MQTT is it's about plugging devices into infrastructure instead of devices to devices. So why does it exist? Okay, well, traditional communication patterns like HTTP which was request response, or direct device polling, all the legacy protocols we see in industry, okay, including OPC, have fundamental limitations for IoT and IIoT, industrial applications. So HTTP, always on, devices must constantly poll for updates, has high overhead, very big headers, and connection setup consume a lot of bandwidth. Client-server coupling, devices must know the specific server endpoints. We call that determinism. They are deterministic. We have to know both the producer and consumer over HTTP, and there's no real-time push. Okay, even if you're using WebSockets, I mean, WebSockets kind of overcome this. Servers can initiate communication to devices. Direct polling problems, so legacy protocols in industry. Bandwidth waste, you're continuously asking anything new. I call it the round robin technique, even when nothing changed. Okay, well, also, while you're asking device A for anything new, if you don't have an open thread, you're not asking device B while you're waiting for device A's response. Okay, scalability issues. Each new consumer requires separate polling connections. That's my AB reference. Network inefficiency, multiple clients polling the same data source. Okay, this OPC server was supposed to solve that. MQTT solved these problems by decoupling data producers from consumers through a central broker that routes messages based on topics, which are semantically organized, which are easily read by human beings. So how does it work? MQTT, the core architecture is publisher, publishing client into the broker, many clients publishing into the broker, semantically organized data, and then subscribers subscribe to namespaces or individual topics. So a publisher sends a message to a topic, like a folder, not really, I don't like the channel reference. MQTT broker receives and routes the messages to people who have said, hey, I want to subscribe to this stuff. If anything changes, send me an update. Subscribers receive the message from topics they've subscribed to. Publishers and subscribers never communicate directly. They talk through the semantic hierarchy in the broker namespace, through the MQTT broker. So key concepts. Topics are hierarchical message channels. We call them semantically organized. That is readable by human beings in an organization structure that makes sense to human beings. This is why large language models work so well with unified namespace. Okay. So factory line 1 temperature, factory line 1 pressure, factory line 2 temperature. Quality of service levels, okay, so QoS 0, 1, and 2. I'm not going to read in that. You can also do retained messages. So if you don't retain a message, the only person who's going to receive a message, the only client who's going to receive a message they've subscribed to is one that is connected to the broker at the time the message was sent. With retention, the value is saved in the broker, and when the client reconnects, the message is sent to them, okay? And then there's also last will and testament. Message is automatically sent when a client disconnects unexpectedly. All right, benefits of MQTT. So bandwidth efficient, decoupled architecture, it's real time, and it's network resilient. So what I like to say is it's edge-driven, report by exception, lightweight, and open. For scale, many-to-many, it's topic-based routing, and broker clustering. We can horizontally and vertically scale by connecting many brokers together. All right, MQTT 3 and MQTT 5 key differences. All right, so MQTT 3.1.1, which is 2014. It's the stable, it's the MQTT that nearly everyone knows, okay? 95% of you are working with MQTT 3.1.1 when you are working with completely flat MQTT, all right? So it's simple, it's proven, it's got broad industry support because it's really very simple to adopt, has a minimal feature set focused on messaging, and it's a very short specification. MQTT 5, which came out about 6 years ago and still struggles to have wide adoption, even though it's got all these great features in it, and that should tell you something, okay? Simplicity is important is what it should tell you, and that so much of what's in MQTT 3.1.1 is what people need. That's why MQTT 5 hasn't been widely adopted. And then Sparkplug is even more complex. The more complex we get, the less adoption we get, okay? So we can be critical of technology, but you also need to be self-aware of the needs of the consumer. That is, you start with the fucking problem and work your way back to the solution. Okay? MQTT 5, major differences. Okay? And I had to really think about, okay, which are the major differences I want to include? All right? Because I don't want this video to be 45 minutes. So, first and foremost, enhanced error handling. Okay, when you see an error in MQTT 3, it's very generic. It's really difficult to understand what the error actually was. There's no detail. So number one, MQTT 5 gives us much more explicit error handling when it comes to client connections. And anybody who's worked with MQTT brokers knows that you really want the MQTT 5 error handling when you're trying to diagnose some issue with your broker when you've got thousands of clients connected. Okay. Number two, user properties is a big one. Okay. There is no metadata support in MQTT 3 for the user. Okay. However, in MQTT 5, we have key value pairs for custom metadata. All right. Message expiration. This is a massive one. Okay. In MQTT 3, a message will sit in the broker waiting to be sent forever. You have to go clear the queue yourself. MQTT 5, however, has time-based. So you can basically say every hour, I want you to clear a message that hasn't been sent. Okay. Request response pattern. In MQTT 3, there's only pub sub. There is no native request response. Okay. So that is, think REST endpoint, right? But MQTT 5 put in native request response support. So you can have a request topic called device command and a response topic, device response client 123, and the data, the correlation data request ID 456. Okay. Shared subscriptions is another big one. So you can put clients into groups, and then those groups can subscribe to the same things. And then when any value in the group changes, it gets published to the entire group. Okay. Flow control. You have basic flow control versus via quality of service in MQTT 3. You have much more advanced flow control mechanisms in MQTT 5. And then you also have enhanced authentication in MQTT 5. All right. When do you use which one? Okay. You use MQTT 3, and why 95% of you are using MQTT 3? When simplicity matters. I have a value, I have a timestamp, I want to publish it to a place, and I want someone to get it. That is 95% of the use cases. Literally, it's 95%. Okay? Choose MQTT 5, all right, when you need the enterprise features. That's at the end of the day, when I want I want to build endpoints in my broker, when I want advanced authentication, I want advanced error handling. I want all the enterprise stuff I care about. The fact of the matter is, once IT starts getting involved, MQTT 5 is of your choice. Okay? What's the bottom line, though? Okay, so MQTT revolutionized IoT communications by providing an open, lightweight, edge-driven report by exception protocol. Okay? Its pub-sub model enables real-time efficient communication across unreliable networks and reliable networks, while decoupling producers from consumers. Okay? So I don't have to have permission for every consumer to talk to every producer. I have to give it permission to talk to one producer that semantically organizes all the messages that come from all of the producers. Okay? MQTT 3 remains the workhorse for nearly all deployments, offering simplicity and broad compatibility. MQTT 5 adds the enterprise-grade features. But for industrial applications, apps like those using Sparkplug, MQTT 3 is typically preferred. You want to know why? Because Sparkplug and MQTT 5 have a lot of overlapping features. So MQTT 3 came along, then Sparkplug A and B, then MQTT 5. Okay, and now you've got Sparkplug 3, right? All right, so what is Sparkplug? And I'm gonna fly through this, but I'm gonna explain the meat of it, and you'll see all the text. And I'll put this in some post somewhere. So what is Sparkplug B? It's an open source spec managed by the Eclipse Foundation that defines how to use MQTT in mission-critical real-time and IIoT apps. Developed by CirrusLink and now managed by Eclipse, it provides a standard framework for industrial devices and applications to communicate reliably using MQTT. Here's the deal. Sparkplug is a specification that solves some specific problems. Number one, if I want to package all of my topics into a device, I want to say that all these topics are a device, and I want to publish those into a broker. How do I do that? If I want to encode the messages so that I'm not sending these big, long text messages, I'm going to go ahead and code them. I'm going to send them as binary over the the wire, and then I'm going to decode them on the other side, Sparkplug solves that message. The big issue, the big thing that Sparkplug does is it enables real-time safe process control. So if I want to control equipment, if I want to use MQTT for the messaging to change bits inside my PLC, Sparkplug is the mechanism to do that. Okay? All right. So while MQTT is the de facto standard for IoT messaging, it was designed to be completely open and flexible, and it doesn't specify these three very important things. Okay? Number one, topic naming conventions. Any topic structure is valid. Number two, payloads can be any binary data, and oftentimes they are just flat text. Okay? And session state management. There's no standard way to track device status. So if I want to put everything together and say all these messages are coming from this device, there's no mechanism, there's no standard mechanism to say this is the state of the device, the abstraction wrapped around all those topics. This flexibility is MQTT's strength for general applications, but it creates problems for industrial applications where multiple vendors need to natively talk to one another. Okay, Sparkplug gives you the ability to take a Opto22 PLC, publish over Sparkplug B directly into Ignition and create Ignition tags, just like that. Okay, real-time state awareness for critical SCADA systems. The PLC is up or down. The PLC, not we didn't receive a message, but the device itself is connected or it's not connected. All right, bandwidth efficiency for essential remote locations. We're going to go ahead, compress, and we're going to encode. Okay? Data integrity and reliable delivery are mandatory. That has to do with the messaging structure. So before Sparkplug, every MQTT implementation in industrial settings was proprietary. It was. It was open, but the way you structured it was unique, was proprietary. Okay? Preventing plug-and-play compatibility. So how does it extend? Well, it doesn't change MQTT. It just defines some of the missing pieces. And I'm just going to skip through this, but standardized topic namespace. So everybody, all Sparkplug messages are published into Sparkplug B v1.0, and then at the client, at the node, you define the group you're going to publish into, and then message type would be something like ddata, and then you have the edge node ID and the device ID. People ask me all the time, what is the difference between an edge node and a device? Okay, think of it this way. You have scenarios where the edge node might be something like Ignition Edge. I may have an instance of Ignition running on the edge. Ignition is talking over specific proprietary protocols, okay? It might be talking to a Rockwell PLC, might be talking to a Siemens PLC. Now, what I will have is I will have the ID for Ignition Edge, the piece of software that is talking to two different devices, one Rockwell PLC, one Siemens PLC. And each of those PLCs will get their own ID, okay? However, in the case of an Opto22, the gateway, the edge node, and the device are the same thing. Okay? The gateway is running on the device. Therefore, the device becomes the edge node. That's why the device ID is optional. Okay? I guarantee what I just told you there, 99% of people who work with Sparkplug don't know. Okay? That's the difference. That's why device ID is optional. Okay? So you have Sparkplug V. This identifies which version. It's where the other Sparkplug clients go to look for other Sparkplug messages. The group ID is a logical grouping. This is almost always like a site. Okay? So it's normally, the group ID is almost always a site. You got the message type. So NBirth, DBirth, NData, DData. Those are the ones you guys know the most. NCommand, DCommand. Ndeath, ddeath, and state. Okay? The ones that you see the most when you just want to see the values of the data, there you go. Ndata, this is it's basically the first message that's published that basically says this is the structure. Here are the messages that we're going to receive. Okay? There's efficient binary payload encoding. We have session state management. We have a hierarchical device architecture. And the key benefits for Sparkplug. Opinions vary. Okay? For system integrators, plug-and-play interoperability, reduce integration time, standardized approach to MQTT implementation, assuming you are using Sparkplug for what it was designed for. Okay, for the problems it solved. Okay, for operations, real-time state awareness of the devices. Regular MQTT doesn't allow you to have a standard way of monitoring the health of the PLC. Is it connected? Is it not connected? Okay. Efficient bandwidth usage for remote cellular connections, reliable data delivery, and then for IT-OT convergence. It is the bridge between IT and OT. Okay, it is. All right. So real-world application. Let me just skip that part. Let's get to the bottom line because we're getting long, and I want to go through these images. Sparkplug B transforms MQTT from a general-purpose messaging protocol into a complete industrial communication standard. It provides the structure, efficiency, and reliability that industrial applications require while maintaining MQTT's inherent scalability and decoupled architecture. This makes it possible to build truly interoperable, vendor-neutral industrial IoT systems that can scale from a single machine to entire manufacturing enterprises. This is a very simple, this is from iFlow, this image, but this is a very simple, this is a device. This is an edge node, and it could be something like ignition or some gateway, okay? And then we have a grouping, a logical grouping, where maybe we're publishing both of those edge nodes into the same group, which would be whatever location. And then the client here is going to subscribe to that location, and it's going to get all of the devices, 6 devices, organized 3 in one edge node, 3 in another edge node, okay? And then they can do control back and forth between the two. So real quick, edge and network node, MQTT client that manages the session. The device is connected to the edge of network node, the gateway, via legacy protocols. This would be like a PLC. So I'm creating a logical grouping for the PLC, or for the gateway. And then the device, I'm creating a logical grouping. I'm basically saying all these tags are from this device. And then I'm calling it whatever device, Rockwell PLC. And then I am publishing it using this edge of network node, which would be the software or the gateway that is connected to the device. Okay. The edge of network node publishes a birth and death on behalf of the devices. The device messages include the device ID in the topic. The MQTT enabled device acts as its own edge of network node. What this is saying is when I'm using an Opto22 that is both a device and a gateway, okay, it acts as its own gateway. So I'm not having to group it Opto22 to ignition. So where ignition would be the name of the edge of network node, Opto22-1 would be the PLC. What I'm going to do is I'm going to have Opto22-1 as the edge of network node. And what I would be signifying to the consumer is this acts as its own device, semantically. You also have the hybrid edge of network device reports its own I/O as edge of network metrics. That an Opto22 does that as well. And then external devices still use device ID topics. Here's a list of all the message types and topics. So dbirth, ddata, dcommand, ddeath. So dbirth is for external devices only. Ddata is for external device data. Okay. Dcommand commands to external devices. Ddeath is the death certificate. Okay. Nbirth includes its own I/O and gateway metrics. Ndata reports its own I/O changes. Ncommand commands to its own I/O, and ndeath is the death certificate. All right. So I have a couple of examples here. I have an edge of network node 1 and 2, and then I have an Opto22 Groove Epic. Okay. So what I've got is a gateway. Our node is a gateway. That gateway talks to device A, which is a PLC, device B, which is an RTU, and device C, which is a simple sensor. Okay? This gateway creates the logical structure for the values that come from each of these 3. Each of these 3 get their own device ID. So there's 3 devices here, and then 1 edge of network node. That is then we set up an MQTT client session, and it gets published into the broker. We do the same thing for use case number 2. In this case, I have device D, which is a flow computer, and device E, which is a smart transmitter. We have 2 separate edge of network nodes. and we have 5 total devices. Okay, and then we have the Opto22, which is the Opto22 is publishing its own data as an edge and network device, and then we have a logical diagram for how messages are handled in Sparkplug B. Okay, all right. So back to the my original point. Okay, back to my original point. So what Jeff said was manufacturers should reconsider their use of MQTT and Sparkplug B if they spend more time engineering around it than making use of it. And I would argue, Jeff makes a good point. It is a good point. But I would argue the problem is not that they selected MQTT and Sparkplug B. The problem is that they don't understand the technology. They don't understand where MQTT came from or Sparkplug came from and what problems they solve. And we shot a video last week. I literally focused on the fucking problem. Okay, start with your problem and work your way back to the solution, like Dave Schultz says here. All right, with that, like, subscribe, comment down below, and I'll see you in the next one.